So, welcome to this first video of combinatorics, number theory problems. So this is the first problem that has appeared in NEST 20 in the examination of NEST 2019, and this is a very kind of arbitrary and trivial problem, but we'll solve it with the help of mathematics. So, the question says how many two-digit numbers are there which are divisible by both of their digits. Okay, so for example. If we just talk about what the question says, for example, if we take a two-digit number 22, it is divisible by both of the digits, because 2 is also part of 22, and both of the digits 22 is actually divided by. So their one digit is its one digit is 2, and its another digit is 2. So it is divisible. For example, 33, it is also divided by 3 and 3. So how many digits are there which are divided by both of their number? For example, 32, its digit are 3 and 2. So, but 32 is not divided by 3, but it is divided by 2. So this is not our number. Okay. For example, 24, its digit are 2 and 4. And 24 is divided by 2, and 24 is also divided by 4. So this is one of our numbers. So we have to find how many of such numbers are there between 10 to 99. Okay, because we are asking because the question says all two-digit numbers. Okay, so we know that two-digit numbers can be written in the form of 10a plus b. Okay, where a and b are integers. Okay, so but we can solve this question by simple counting. We all just start writing numbers from 11 to 99, and you will just select the required numbers, but that too hectic. But if we use a little bit of mathematics, we will be able to eliminate most of the cases, and then we'll be left with a little less work. Okay, so of course the number that are obvious are 11, 22, 33, 44, 55, 66, 77, 88 and 99. This number would be, of course, divisible by both of their digits. It's very trivial. But what else? For example, we saw 24. So what else? So let's solve it. So this is general form of a two-digit number, 10a plus b. Okay. It says that it is divisible by both of their number. Therefore, 10a plus b by a is also an integer. And 10a plus b by b is also an integer. Both has to be integer because it is perfectly divisible. So both has to be integer. Okay. Now here it says 10 plus b by a is integer, and here it says 10a by b plus 1 is integer. Okay, that's the question says. Now here we can say that first let's talk about this. So here we can say that b must be a factor of 2 and 5, because if it is factor of 2 and 5, then it will divide 10. Okay, and it will be an integer. And if it is neither a factor of 2 nor a factor of 5, then it must be a factor of a. Okay, because if it is a factor of a, then it can divide a, this whole thing, and it will give rise to an integer. Or here we can say that a must be a factor of b. Okay, this is what we can see here. Only then it will give rise to an integer. Okay, so from these two statements we can find out that b must be greater than a. Only then it is trivial, because if b is not greater than a, this will not give rise to an integer. And here if b is greater than A, it can, because this has to satisfy the condition in both cases. So B must be greater than A. Now if we get this thing right, then we can simply say that we don't need to count numbers beyond 40, beyond 50. 50 के बाद हमें गिनने की ज़रूरत नहीं है, बिकॉज अगर हमने 50 के बाद कोई नंबर ले लिया, फॉर एग्जांपल 57 लिया, सो वी वुड फाइंड that this is actually written as 10 into 5 plus of 7, and we can say that 7 is actually playing a part of B and this is A. So this satisfies the condition B greater than A, but the condition, one more condition was B must be a factor of A. Here B is not a factor of A. Okay, but and so that's what the problem is. So we don't need to count numbers beyond 50. Okay, so all we have to do is to count in between 50, and we can simply count it, and those numbers would be 12, 15, 24, 36 and 48. Okay, so these are 5 numbers here and 9 numbers here, so I think 13 would be the answer. So there were 13 numbers which are divisible by both of the digits. Okay.